Hey y'all, in this video we're going to go over questions 3 through 5 on the Test 2 study guide over vectors. So starting with question 3, we have a bug crawling 5.25 meters along the base of a wall. It reaches the corner, the bug's direction then changes from going south to going west. The bug then crawls 3.75 meters before stopping, and we want to determine the resultant vector for the bug. So your first step is, of course, to draw this out. So your bug is going 5.25 meters, and it's going south, so we're going to go south, and then it says it turns the corner and starts going west, and then goes 3.5. So 5.25 south, then it's going to turn at that corner and go west 3.75 meters, right? So then we want to draw our resultant vector. That's going to start where we first started and end where we ended. So we get our right triangle out of this. The angle we're ultimately going to find is this top corner because that's the angle where we first started drawing at. So now our next step will be to find the magnitude, and since we have a right triangle, we can do that using Pythagorean theorem. So we'll take the legs of the triangle and square each of those and add them together. So 5.25 squared plus 3.75 squared equals r squared. All right, so then when we simplify this left-hand side in the calculator, that's going to equal 41.625 will equal r squared, but we don't want to stop there. We want to square root both sides, and when we do that, we end up with 6.5 for our magnitude, and that's the value of r. So that's our magnitude. You don't want just the magnitude. We want the entire resultant vector, so that includes direction. So we need the direction that this vector is going. So it is going at an angle. So we need to find out what that angle is. So we're going to do that using inverse tan. Technically speaking, you can use any of your inverse trig functions, but I just stick to tan because it works for all of them. All right. So inverse tan, opposite side, opposite of our angle is 3.75. It's the side of the triangle that's across from your angle that you want. And then your adjacent side is the side of your triangle that is touching that angle. So 5.25 is the one touching it. All right. So we'll type that in the calculator. Make sure you are in degree mode, and we are going to get an answer of 35.5 degrees for that. All right. So we don't need, for our direction, we don't just need the angle. We also need which way that angle is going. So we're looking back at our triangle. If we were to draw like a coordinate grid right here, or a compass at that corner, we can see that this angle is touching the south angle, and it's going towards the west of it. So our angle here is going to be west of south. So then to make our final answer, we're putting all the pieces together. We're going to take our magnitude of 6.5, and the units were in meters, at 35.5 degrees west of south. So that's our answer for number 3. All right, moving on to question 4, we have a student walking 10 miles east, then 4 miles north, and we're going to determine the resultant vector for the student. So for the first step, of course, is going to be to draw it. So your student goes east 10 miles, and then turns and goes north 4. And remember, you're drawing these one after the next. Then your resultant vector will make your hypotenuse of your right triangle, and then the angle you want is the corner where you first started drawing. So now we can use Pythagorean theorem to solve for our magnitude. So 4 squared plus 10 squared equals r squared. Then when we simplify the left-hand side here, we're going to get 116, and that's equal to r squared. And then we want to square root both sides, and that will give us 10.8 for our value for r. So that is our magnitude. Now we want to find the angle that our resultant vector is going. So we're going to use inverse tan for this. And so 4 is the opposite side, 10 is your adjacent side, and that will equal your angle, which is going to be 21.8 degrees. And remember, put your calculator in degree mode, not radians. Right? And then the last thing is we need to know which way this angle is going, and we can put a compass right here, and we can see, oh, it's touching the east axis, so that's going to go second, and it's going above it, so it'll be north of east. So now we want to put all the pieces together, and we get 10.8 miles, because that's the unit given to us in the question, going at 21.8 degrees north of east. And we are done with question number 4. All right, so last one for this video is question 5. We have a runaway dog walking 0.7 miles due north, and then turns and goes west to a hot dog stand, and the magnitude of the dog's resultant vector is 1.5 kilometers. What is the magnitude of the dog's component vector in the due west direction? So we're already given the direction it's going. We just want to solve for magnitude. So your first step is always to draw it out. So the dog goes north, 0.7, and then is going to go west, and we don't know what that is. And then we have the resultant vector given to us is 1.5, right? So we just want to find out what this question mark is. So we're going to call this B since we use A, B, and C in Pythagorean theorem. So for Pythagorean theorem, we're going to plug in 0.7 for A, and that's going to be squared plus B squared equals your resultant vector squared, or hypotenuse, is 1.5 squared. Now we want to rearrange this to get B by itself, so we're going to bring over the 0.7 squared to the other side. So it'd be 1.5 squared minus 0.7 squared. When we simplify that in the calculator, we're going to get 1.76 equals B squared, and then we want to square root both sides, and that will give us a value of B as 1.33. So this B right here is 1.33, and the units was in kilometers. So your answer is 1.33 kilometers, okay? So remember, when you're solving for the leg of a triangle using Pythagorean theorem, you're going to either set it to A or set it for B, okay? All right, well, that's it for questions 3 through 5. If you have any questions or need help, just let me know.